Video I'm going to discuss about peroxide effect on the electrophilic addition of HBr. In this reaction, HBr is added to isobutylene in the presence of peroxide to give you 1-bromo-2-methyl propane, which we call anti-Markovnikov product. In the absence of peroxide, HBr would have been added in such a way that bromine would have been added to the most substituted carbon, which we call Markovnikov product. Then what happens in the presence of peroxide? Normally, the addition of HBr to the alkene goes through electrophilic addition. But here, in the presence of peroxide, it goes through free radical mechanism. So this is the reaction mechanism. Any free radical reaction consists of three steps. First, chain initiation step, chain propagation step, chain termination step. In the chain initiation step, you generate a free radical. For example, here, peroxide dissociate homolytically to give you the oxy-free radical. This in turn reacts with HBr to give you the free radical of interest, Br. Then this enters the propagation step. In any propagation step, generation of one free radical will be consumed and it will generate another free radical, which in turn will create a chain of free radical. That's exactly the reason this step is called propagation step. Let's get to the important point. Here, when bromine is added, it is added to the least substituted carbon. There are two reasons for this. Because bromine is bulkier, it will tend to add to the least substituted carbon, which is less sterically hindered. On the other, and also it will also give you the most substituted tertiary free radical, which is more stable. But if I added bromine to the most substituted carbon, then I would have ended up with primary free radical, which is less stable. And that's exactly the reason the bromine is added to the least substituted carbon to give you the most substituted stable free radical. And the second step is simply the abstraction of H from HBr to give you the product of interest. In the chain termination step, two free radicals combine to give you stable product, and there is no generation of free radical. So your free radical will be consumed and there is no generation of a free radical. That's exactly the reason this step is called termination step. Now we have to discuss an important point. Why HCl and HI will not show peroxide effect? For HI, this step is endothermic, and for HCl, this step is endothermic. And for these reasons, HI and HCl will not show peroxide effect. Thank you.